matter: solid, liquid, and gas. Solids have fixed shape and volume, liquids have a fixed volume but no fixed shape, and gases have neither fixed volume nor shape. The changes of state diagram is represented over here, where we have boiling, which occurs at a fixed temperature, and evaporation, which can happen at any temperature. When talking about cooling and heating curves, on heating, solids expand, and at the melting point, the energy is used to break the bonds, converting the solid to a liquid. On cooling, the gases condense to liquids, which then solidify at freezing points. Diffusion is simply when particles move from areas of higher concentration to a lower concentration, whereby gases diffuse faster than liquids due to the particle spacing. Factors that affect diffusion are temperature and mass. Increasing pressure compresses the gases, while increasing the temperature increases their kinetic energy and volume. Atoms consist of protons, neutrons, and electrons in a shell around a nucleus. The number of protons defines the element, which is the atomic number, while the total number of protons and neutrons give the atomic mass. Isotopes are atoms with the same number of protons but different number of neutrons, and isotopes of an element have the same chemical properties but different physical properties. When talking about bonding, we have three types of bonding: metallic bonding, which is localized electrons which create a sea of electrons, allowing metals to conduct electricity and be malleable. We have covalent bonding, which is where there is shared electrons between atoms to form strong bonds like in water or carbon dioxide. And we have ionic bonding, which is the transfer of electrons between atoms which forming charged ions. An example is NaCl. Formulas and equations: we have the molecular formula, which gives the actual number of atoms in a molecule, while empirical formula gives the simplest ratio. When balancing chemical equations, it ensures the conservation of mass. A mole represents 6.02 times 10 to the power 23 particles of a substance, which is the Avogadro's number, and the molar mass is the mass of 1 mole of a substance. Electrolysis is the breakdown of an ionic compound using an electric current. Positive ions move to the negative electrode, which is the cathode, and negative ions move to the positive electrode, which is the anode. Redox reactions involves both reduction and oxidation. Reduction is the gain of electrons and oxidation is the loss of electrons. Reduction occurs at the cathode and oxidation occurs at the anode. Something that you need to know or is a useful mnemonic is oil rig, which is oxidation is loss, reduction is gain, and panic, which is positive is anode, negative is cathode. Exothermic and endothermic reactions. In exothermic reactions, energy is released, causing the surroundings to warm up, and with endothermic reactions, the energy is absorbed. When talking about energy level diagrams, you need to show the energy change in a reaction. Exothermic reactions have products lower in energy than reactants, and endothermic reactions have products higher in energy. When talking about bond energy, energy is required to break the bonds and released when forming the bonds. The difference in bond energies determines if a reaction is exothermic or endothermic. What are the factors that affect reaction rates? Temperature, surface area, and catalysts. The collision theory involves reactions which occurs when particles collide with sufficient energy, which is the activation energy. Equilibrium is a dynamic state where the forward and reverse reactions occur at the same rate. Changing conditions, for example temperature, pressure, and concentration, can shift the equilibrium, either to the left or to the right. Acids are proton donors, producing hydrogen ions. They react with metals to produce salt and hydrogen gas, with bases to produce salt and water, and with carbonates to produce salts, water, and carbon dioxide. Bases are proton acceptors, producing hydroxide ions. They neutralize acids. Salts are formed from the reactions between acids and bases, and soluble salts can be prepared using excess insoluble base or using titration, while insoluble salts are prepared through precipitation. When talking about the periodic table, we need to look at the group trends. Group 1 are highly reactive metals, with reactivity increasing down the group. They react vigorously with water, producing alkaline solutions and hydrogen gas. Group 7 elements, which are halogens, are nonmetals, and they are diatomic molecules which with reactivity decreasing down the group. We then have transition elements, which are metals with variable oxidation states, forming colored compounds and acting as a catalyst. Noble gases are group 8, which are inert gases with full outer electron shells, and they're used in lighting and as unreactive environments. Metals, the properties of metals are they're good conductors of heat and electricity, they are malleable, they're ductile, and they're usually solid at room temperature. In talking about the reactivity series, metals are ranked by their reactivity with water, acids, and oxygen. More reactive metals displace less reactive ones in a chemical reaction. Alloys are mixtures of metals that are harder and more resistant to corrosion than pure metals. What is corrosion? Corrosion is rusting that occurs when an iron reacts with water and oxygen, forming hydrated iron oxide. Rust can be prevented using barriers or sacrificial protection. When talking about chemistry of the environment, we talk about water treatment, air pollution, and climate change. With water treatment, water is filtered and treated with chlorine to remove impurities and kill bacteria. With air pollution, common pollutants like CO2, methane, sulfur dioxide, and nitrogen oxides contribute to global warming, acid rain, and health problems. When talking about climate change, we talk about greenhouse gases that trap heat, leading to global warming. With organic chemistry, we have 4 main types of groups that you need to know. Alkanes, alkenes, alcohols, and carboxylic acids. Alkanes are saturated hydrocarbons. They only have single bonds. And they're relatively unreactive, but undergo combustion to form carbon dioxide and water. You can also do cracking of alkanes to form alkenes. Alkenes are unsaturated hydrocarbons with at least one double bond, more reactive than alkanes, and undergo addition reactions with bromine, hydrogen, or steam. Alcohol are organic compounds with OH functional groups, and ethanol can be produced by fermentation or by adding steam to ethene, used as solvents and fuels. The last group is carboxylic acids, and organic acids with COOH functional group. They're used in food preservations and chemical production.